Hi everyone, I'm Ruofei, a fifth-year PhD candidate at UCLA. I'm really happy to present this work, UI Mobility Control in XR Extended Reality, Switching UI Positionings between Static, Dynamic, and Self-Entities. It was done in collaboration with David Kim, Alex Olwal, Zhang, and Ruofei during my internship at Google. UIs are user interfaces, like your browser tabs, a slide deck, a digital name card, etc. As extended reality grows popular, user interfaces are no longer bounded by device screens. UIs can appear virtually anywhere. We observe that when describing a UI placement in 3D environments, it is oftentimes natural to describe a UI with a host entity, an entity that the UI is attached to or placed around. For example, on the wall, by my side, or above her head. We categorize these host entities into three types. Static entities, which means fixed objects or surfaces like walls or tables. Dynamic entities, such as living beings and moving objects, like moving people or animals. Self-entities, which include head zone, torso surround, and hand area in my personal space. We surveyed 113 XR apps on the HoloLens App Store and focused on apps that facilitate daily activities instead of gaming. The x-axis is a percentage and the y-axis is a type of UI an app has. We can see that the majority of XR apps place a variety of UIs in the space, and we envision even richer UIs for the future XR ecosystem. This motivated our work, which is to explore and facilitate UI mobility control in extended reality. In our survey, we noticed that a UI usually remains attached to the same entity. This observation contradicts the frequent movement of UIs on 2D screens, for which many prior works have proposed a suite of interaction techniques. Moving a UI in XR has yet to be fully explored. So we wonder, what will happen if we allow users to freely and naturally move a UI between entities? This is exactly what we dive into, to investigate UI mobility in XR. In response, we did a thought experiment with 11 participants for need finding. We asked them to imagine a world where everyone has AR glasses and imagine being able to move the UI seamlessly between the static, dynamic, and self entities. Participants wrote down when they needed a UI to move. We picked 3 of their needs to share with you. The first one is, pin my reminder, drink water, to the lab entrance. The reminder UI was attached to the user. Now, they wanted to stay beside the lab entrance as an in-situ reminder, so they will remember to drink water before going into the lab. The second scenario is, drag a thermostat UI on the wall to my screen space so I can touch it without walking to it. The UI was on the wall, but the user wanted it to be closer to interact with. Now, the UI is brought to the personal space. The third scenario is during an academic conference. A participant fails to recognize another person. Assuming everyone has a digital name card above their head, the participant would love to drag the digital name card to personal space to read it carefully and probably click collect. In this way, we organize users' needs in a table. Please refer to our paper for details. Beside the thought experiment, we are curious. Can we prototype a system to cover all these needs? How will users react to it? Therefore, we recruited 14 participants aged from 23 to 36 to our final study. In the final study, we simulated 3 daily scenarios: teaching in a classroom, meeting in a conference room, and go sightseeing on a touring bus in the national park. As prior art only covers a subset of UI mobility control, we also propose a probing interaction technique called FingerSwitches. We turn the large portion of the index finger into a 3-mode switch, and our thumb can swipe or tap the index to indicate the desired UI transitions between entities. Pinching the index tip refers to static entities. Middle of the index indicates dynamic entities, and pinching at the root of index means self-entities. This is a close-up look of the finger switches. Now, let's see how users use UI mobility in classroom. The user acts as an instructor conducting a discussion session. Students can share their opinions with Thought Bubble UI. Here, the user looks at the target bubble, pinched and held the root of the index finger, then look at the landing spot, and release the pinch. The gesture refers to self-UI, so the bubble stays in the user's headspace. Then, the user looks at the static target bubble, pinch and hold at the root of the index finger, then look at the hand back. This gesture refers to self-UI, so the UI will follow user's hand. In the conference room, the user acted as a meeting host with colleagues. The user first looked at the slide deck UI in the headspace, pinch and held the tip of index finger, and look at the wall, then release the pinch. This gesture refers to static UI, so the slide deck stays on the wall. User can also adjust the position a little bit with the same gesture. Now it's another UI, the action items. The user look at it, pinch and hold the middle of the index finger, then look around to see who is a candidate receiver. Finally, the user releases a pinch at Abby. The to-do list will follow the person Abby. This time, a music player UI in user headspace. The user look at it, pinch and hold the root of index finger, then look at the hand back before releasing. Now, the UI is on hand back for easier interaction. Now we are in a national park on a touring bus. The user can spot various wild animals and view their name card UIs, which include their names, habits, and buttons for like and collect. The user look at the name card of the leopard, pinch and hold it, and then released. Now the UI is attached to the headspace. Again, the user look at the name card UI, pinch and hold it at the middle of the finger, then release it at the notebook. Now the UI is attached to the notebook. This time, the user look at the warning signs UI in the forest, pinch and hold it at the middle of the index, turn to her friend, and then release it. Now the UI follows her friend. More applications and details are in the papers. After experiencing all of this, users reported that the usefulness varied across types of entities. Most users appreciated moving a UI to a static entity. Also, 13 out of 14 users liked the ability to move a UI to their personal space. Besides, 10 out of 14 users expressed moving a UI to a dynamic entity was useful when sharing digital content on the go. Please check out our paper for more details, other findings, and design implications. In summary, our work aims to raise attention on UI mobility in XR. We discover user needs and explore common practices. We also facilitate UI mobility with a probe interaction technique, FingerSwitches, and a wide variety of applications. Thank you for listening. Bye!